I've heard there was some problems with this, especially from those of you at home, so I want to kind of give you a run-through of this activity, or an example of a run-through of this activity. So first of all, though, if you've not read the instructions, I really think you should go to Classroom and read the instructions on what we're going to do here. Okay, that will make this make more sense. So let's start off here. Our first process. Wildebeest drink from a watering hole and urinate. Take up nutrients only if you have the correct soil microbe card. Well, we don't have any soil microbe cards yet, so while we could have this, if we had the microbes, we can't use any of it because we don't have the microbes yet, so this is going to be discarded. Next, animals eat organic compounds from energy and respire CO2. Take up carbon. This one doesn't require soil microbes, so we'll see we've got 6 carbon here. All right, and 0 nitrogen and 0 phosphorus. All right, so let's... All right, there's our carbon. Next, inorganic minerals leach into groundwater. Take up nutrients. Oh, take up the nutrients, right? All right, so this one does not require, this is groundwater, this does not require soil microbes. We can come down here. It says we receive 1 phosphorus there from the groundwater. Okay. Looks like our phosphorus is taken care of. Aha, a soil microbe. Bacteria decomposes complex organic matter into inorganic forms that are available for plant uptake. Nutrient uptake enabled. Keep this card. We're going to put this down here in our soil microbe here. Now what do we have? All right. Wildebeest dies and soft tissue decomposes. Take up the nutrients only if you have the correct soil microbe card. All right. So here we go. Nutrient uptake enabled over here. So that means, yes, this one works. So we get 6 carbon, 1 nitrogen, and 1 phosphorus. All right, our 6 carbon, 1, 2, 3, 4, 5, 6. Our 1 nitrogen. And we already have a phosphorus. We only needed 1. So our phosphorus is completed. So that means this phosphorus is just going to stay in the ground for right now. What do we have next? Ammonifying bacteria convert organic forms of nitrogen into ammonia, a form used by plants. Nutrient uptake enabled. Keep this card. So now we've got a couple of different soil microbes. And for the simplicity of this game, they both do the same thing with nutrient uptake enabled. Obviously, in real life, it would be slightly different. So, here we go. Wildebeest graze and defecate. Take up the nutrients only if you have the correct soil microbe cards, which we do. So 6 carbon, 1 nitrogen, and that phosphorus that we're not going to use again. 6. 1 nitrogen, and still we're good on the phosphorus. Next. Bacteria decomposes. I think we have this exact same one over here. So we'll just go ahead and discard this just for the process of this game. But animals eat organic compounds for energy and respire. Take up carbon. All right, 6 more carbon. Wildebeest graze and defecate again. Right? 6 carbon, a nitrogen, and that same phosphorus. All right, it now looks like our carbon is complete. Right? Our phosphorus is good, so that means we still have a lot of nitrogen left that we have to try to find, though. Denitrifying bacteria convert nitrate into N2 gas that escape to the atmosphere. No nutrients available, discard this card. Yep, so this is a bacteria that ends up taking some of that nitrogen that's in the soil and turning it back into nitrogen gas found in the atmosphere. Doesn't help the plant right now, at least in the short term. A detritivore. Termites transport and break down complex organic matter. Termite mounds are hotspots for productivity. Double all nutrient upkeep. Keep this card. And this is above ground, so we're going to put this over here in the detritivore category. So now we're able to uptake nutrients from our soil microbes, and because some of these decomposers on the surface are doing a great job at decomposing things, breaking it down into inorganic material, now we get to double our nutrient uptake for whatever we have. So let's see what we have here. Oh, another one. Dung beetles transport and break down complex organic matter. Double uptake for defecation. That would have been helpful beforehand, but we already have this one here. I'll leave this here, but we already have double all uptake. Oh, another ammodifying bacteria. I'm going to go ahead and discard this one because we already have this one down here. So this isn't perfect, but it's an explanation, or it's helping us start to see some of the processes that take place here. All right, plants use organic compounds for energy and respire. This is plants use organic compound for energy and respire CO2. Wait a minute, I thought only animals did that. No, plants respire as well. Everything respires, it's just only plants photosynthesize. But we're already good on our carbon, so we don't need any of that. Plants use organic carbon for energy and respire. Hey, same one. Who shuffled this? Oh, wait a minute. Wildebeest dyes and bones leach inorganic minerals into groundwater. Groundwater again. But 2 phosphorus, we're already good on our phosphorus, so that doesn't do us any good. Inorganic minerals leach into groundwater. Take up nutrients. Oh, another phosphorus. Seems like the only time we see phosphorus is when we have groundwater. Well, that's not true. A little bit of a few others, but. Oh, another denitrifying bacteria. Man, this nitrogen. Tough to get. Wildebeest dyes and bones leach inorganic material into the groundwater again. Still that phosphorus. Oh, look. Wildebeest drink from a watering hole and urinate. Take up the nutrients only if you have the correct soil microbes, which we do, and not only that, but we get to double all of our nutrient uptake. So thank you, Termite Hill. That means we get 4 nitrogen in this case. Five more nitrogen. Wildebeest dies and soft tissue decomposes. Take up nutrients only if you have the correct soil microbes. We don't need any more carbon. We don't need any more phosphorus, but 2 nitrogen off of this one. Once again, thank you, Termite Hills. Animals eat organic compounds for energy and respire. Take up carbon. We don't need any. Nitrogen-fixing bacteria convert from the atmosphere, and okay. Add 1 in every turn. Nitrogen-fixing bacteria convert nitrogen from the atmosphere into forms used by plants. A new one. So this is now one that takes nitrogen from the atmosphere and turns it straight into a usable form by the plants. We like this one. Right? Run out of cards. I'm going to quickly turn this over. Shuffle just a little bit. All right. So this turn, I get 1 nitrogen here. And then let's see what we have. Oh, it's this one again. Wildebeest drink from a watering hole and urinate. Right? So to nitrogen, we have now filled all of our boxes. So hopefully we can see that this nitrogen really needed some soil microbes to be able to get this to work, right? We had some detritivores up here that sped things up a little bit, right? Our phosphorus, right? It seemed like we were only able to uptake that for the most part when things were dissolved into groundwater, right? The only exception to that would have been when some decomposition took place, right? And then our carbon, it seemed like we got it in big chunks. It seemed like carbon was pretty darn easy to get a hold of. We also needed the most of it, right? But all of that was taking place, it seemed like, either through decomposition or also in the air, right? And the plants could take care of that by themselves. They didn't need any other bacteria. So I'm hoping that this run through helps you out, and hopefully you can get some more questions off of this. Let me know what else we need to look at.